Example 1. This is some Chapter 7 review, but we're talking about X bar, the sample mean. This is the sampling distribution problem. We know that the sampling distribution X bar follows a normal distribution since our sample size was very large. We took a sample of 100 tires, so by the central limit theorem, X bar is approximately normal. And I've defined its parameters here. Since we're doing a hypothesis test, let's set up our hypotheses. We'll start with the null hypothesis, H0. The hypothesis testing we're doing will always involve mu. We're hypothesizing or making inference about the population. In this problem, the status quo, or what's believed to be true, is that the population mean equals 36 inches. We'll be testing the alternative hypothesis, HA, if the population mean is actually different from that, or not equal to 36. This is a two-sided test because the population mean can be less than 36 or greater than 36. Both of those fall within not equal to 36. The next step we need is to compute the test statistic in order to run this test. Here I copied the formula for our test statistic. We took a sample of 100 tires and the mean diameter of those tires was 36.4 minus the hypothesized mean minus 36 divided by the standard error of X bar. This is computed above. Sigma over square root n is the population standard deviation over the square root of the sample size, or 0.21. And there's my test statistic, my z-score. We're going to run this test using the rejection region method. This is the decision rule that will determine our conclusion. So we can use this sentence, or it might just be easier to use the picture and draw out the rejection region. At level alpha, let's determine our alpha that's given in the problem. Test at 5% level of significance. Alpha is the same thing as level of significance, so alpha equals 0.05. We know that the z-scores in my distribution all follow a normal distribution. In particular, z, the standard normal distribution, is normal with a mean equal to 0 and a standard deviation of 1. This is a two-sided test with alpha equal to 0.05. So we have two different sides of the rejection region. Or, since alpha equals 0.05, our confidence level is 95%. And we have a two-sided test. Alpha on both sides over two sides. So the area or the probability right here, 0.025. We need to find the z-scores that define those regions. This is my rejection region on either side. If my test statistic that I computed above falls into that rejection region, then we reject the null hypothesis. So let's figure out what this number is. In essence, we're given a probability and we're trying to find a value on the number line of a normal distribution. So this is a norm inverse calculation. I need to enter a left-tailed probability. The mean of the standard normal distribution, z is 0, and standard deviation of 1. So minus 1.96. Because the normal distribution is exactly symmetric, these probabilities are the same. This one is my negative 1.96, and this one automatically, without even calculating, is positive 1.96. Again, if my test statistic that I computed in this part falls into the rejection region, I reject HO. Well, let's check it out. 1.904 falls around there. So it did not fall into the rejection region. Therefore, we can make a conclusion. As my test statistic didn't fall into the rejection region, do not reject the null hypothesis.